Alright, just some examples now on differentiating exponential functions. We're not concerned with the log law ones yet, they will come on later. Just the very basics, differentiating with e's involved. So let's go, just differentiate. And we're going to differentiate question A, we're going to differentiate just e to the power of x. So my rules, definition-wise, my last definition was, well, one of my definitions just then was differentiating e to the power of x will get you e to the power of x. So differentiating that there gets you e to the power of x. That is your answer, you're done. If you have something with a constant in it, so if you're differentiating something like 9 e to the x, differentiating that, d on dx, 9 e to the x, differentiating that, any constant in your differential can come out the front, so you can rewrite this as being 9 d on dx, e to the x, and differentiating e to the x gets you e to the x, so this is going to be 9 e to the x. So again, what you started with. Nice. Getting a bit more tricky. Question C. If you're differentiating something like e to the 4x plus 5. So now we are looking at a chain rule question. There's a video on chain rule, differentiating with the chain rule. The rule says differentiating that there, if you're differentiating e to the f of x, that's equal to f dash x e to the f of x. So just take note, this here is what you start with. That's what you start with as well, it's the same thing. So we're just differentiating f of x here. So my f of x in this example, if you like, is this up here. So differentiating that is going to get us just 4. So my answer, d on dx of e to the 4x plus 5 is equal to 4. That's the top differentiated outside of e to the 4x plus 5. Okay, not too bad there at all. Getting a little bit more difficult. Let's go down a bit. So if I take question D here, if I have something like x squared e to the 3x plus 2, here we now have a few things going on. It's a little bit more difficult. To differentiate that, we have two functions. We've got a function here, that x squared, another function here. So this is going to be a product rule question. So product rule, vuv. Product rule says that y dash equals vuv, vu plus uv, and the dashes go on the last bits there. So separating this out, we'll say that u is x squared. So u dash is 2x. And we're going to have that v equals e to the 3x plus 2. And then v dash. So differentiating this here, same as the above question. So differentiating what's up the top here is going to get me a 3. So this is going to be 3, then e to the 3x plus 2. So by the time I put this together using my product rule, I'm going to get that d on dx of x squared e to the 3x plus 2 is equal to, and then putting it together, v u dash, so v u dash is 2x e to the 3x plus 2 plus uv dash, so uv dash is 3x squared e to the 3x plus 2. Okay. If you want, you can factorize that. You don't necessarily need to. I will just to show you guys because you haven't seen it before, I don't think. So this here is in common between both of them. I'll also pull out an x as well. So the x there, 2x is there. So it's going to be x e to the 3x plus 2, open bracket, 2. So it makes up that whole thing there, plus 3, x. Okay. And if you want, you can move that out to the start if you would like as well. So that's just some simple differentiating questions. You may, of course, be asked to use this to find gradients at particular points. So let's just go. Something a little bit harder. Let's go find equation of the tangent to, let's say y equals, let's go e to the x plus 4 at x equals 3. Okay, so we've got some curve. Oh dear, that's not very nice. We've got some curve like this. We're trying to find the equation of the tangent when x is 3. So x is 3, going to be about here-ish, some tangent off that general direction. So firstly, need to find, well, for x is 3, we need to find a point, need to find a gradient as well. We've got x is 3, so when x is 3, y will be equal to e to the 3 plus 4, or e to the 7. Okay, e to the 7. We can work out what that is if you would like to, or we can leave it in the exact form. Both good answers. So that's our coordinate. Our coordinate is 3 e to the 7. Is the point on the curve. Next we've got to find the gradient. So the gradient, we've got y equals e to the x plus 4 dy dx. So chain rule, differentiate the top is 1. So it says e to the x plus 4. At x equals 3, dy dx equals e to the 7. So my gradient here is also e to the 7. So in terms of working out my equation here, y minus y1 equals m x minus x1. So I get y minus e to the 7 equals e to the 7 x minus 3. I can clean that up a little bit as well. Just keep in mind that the e to the 7s, that one there is from the gradient m, which we did down here. And my other e to the 7, this one here, is from the point up here. Okay. That can be cleaned up. I will clean that up a little bit actually. We'll say that y equals e to the 7x minus 3 e to the 7 plus e to the 7. So from that other side. So y equals e to the 7x minus 2e to the 7. Okay, so my gradient is e to the 7 there. My y-intercept would be minus 2e to the 7, whatever that is. That's my equation on my curve. So you will, like I did up here a second ago, I did a nice product rule question. You will see a bunch of product rule, chain rule, quotient rule coming into it. As you learn more function types, you can expect more combinations of functions, more product, more chain, more of that year 11 calculus coming through. Otherwise, this here is a very bread and butter question. This here is deceptive because it looks so easy, and from a definition's sake, from definition point of view, we know the definition, and it should be simple to differentiate. It's just that it can get confusing where that 9 goes, and then differentiating this, I get that you might freak out when you see that because you're wondering what the trick is. That was our definition there. All well and good to see. Okay. Oh, that was from my previous video. Nice. Alright guys, well thanks for watching and best of luck as you embark on some questions yourself.